So in the previous video, we saw how to find the root of an equation by using bisection method. Now we are going to look at another method called false position method or Regula-Falsi method to find the root of an equation f of x equal to 0. We will try to understand this method through solving a question. So the question here is, find the root of an equation x cube plus 2x square plus 10x minus 20 equal to 0, correct to one decimal place. Since we have to find a root, and by definition of a root of an equation, we know that we have to find some number c such that when we plug it in f of x, we will get 0. But since here we have to find a root correct to one decimal place, so it means that you have to find something like 0.10 because it's a root correct to one decimal place, and the second could be any digit. So how many digits do you see after the decimal? 2 digits. It means you will have to fix your calculator up to 2 decimal places. That's the first thing that we shall do. So this is our goal, that we have to find some number c which when we plug in f of x, it gives us 0.0 and some digit. That is where we will stop. Okay, so let's start this question. To start this, first we shall have to write what is f of x. Look at this equation. So whatever is on another side of 0, that would completely be f of x. So f of x here is x cube plus 2x square plus 10x minus 20. Okay, so just like in bisection method, the step 1 here is to find the interval in which the root will lie. So to find the interval, we randomly plug numbers in the function. We find f of 0, 0 cube plus 2 into 0 whole square plus 10 into 0 minus 20. This gives us minus 20. So we plug 0 in here in f of x, and we get f of 0 as minus 20, which is less than 0. We find f of 1, which is minus 7, which is still less than 0. We find f of 2, 2 cube plus 2 into 2 whole square plus 10 into 2 minus 20. This gives us 16, which is greater than 0. So we have an interval here which is composed of these two numbers 1, 2. And why is this the right interval? Because at one end of this interval, which is 1, the answer is minus 7, which is negative. At another end of this interval, which is 2, the answer or the value of the function is positive. So this is an appropriate interval in which the root will lie. We are just going to name this interval as a0, b0. So this says that a0 is 1 and b0 is 2. After finding the interval, we have to find false points, means we have to find c's, and one of these false points will be your root. Okay, in step 2, we are going to write down the formula for finding the false points. That formula is Cn is equal to an f of bn minus bn f of an whole divided by f of bn minus f of an. And here n is running from 0, 1, 2, 3, and it goes on. Let me call this Cn formula as an equation 1 so that we can refer to it whenever we need. Now when we put n equal to 0 in equation 1, we get C0 is equal to A0 f of B0 minus B0 f of A0 whole divided by f of B0 minus f of A0. Now remember that we have the value of A naught which is 1 and the value of B naught which is 2. So let's plug in these values. We are going to find C naught. A naught is 1, B naught is 2, B naught is 2, A naught is 1 over f of B naught is 2 minus f of 1. Let's also draw the interval. On one end we will denote it by A naught, another end we will denote it by B naught, and we have A naught as 1 and B naught as 2. So for this interval A naught B naught, we will find the first false point, which we will denote by C naught. We know that A naught B naught is an appropriate interval because f of A naught, since A naught is 1 and we have the value of f of 1 as minus 7, and f of B naught is 2 and we have the value of f of 2 as 16. So A naught and B naught makes up an appropriate interval because f of A naught is negative and f of B naught is positive. Now we are going to find the point C naught, which is somewhere in between A naught B naught. Unlike the bisection method, C naught here is not the middle point of the interval. It is somewhere in between A naught and B naught. Let's find the value C naught. Back to this. So 1, f of 2 is 16 minus 2, f of 1 is minus 7 whole divided by 16 minus f of 1 is minus 7. So when we solve this, we have the value of C naught, which is 1.30. On the right hand side in the interval, we will write C naught as 1.30. Please have a look that at A naught the value of the function is negative. That is why we are putting here a negative sign. At B naught the value of the function f of B naught is 16, which is positive, so we are putting here the sign as positive. Now we have found C naught somewhere in between A naught B naught, and then we are going to plug this C naught in the function and we will find its value. The function here is x cube plus 2x square plus 10x minus 20. So we will plug this in the function. 1.30 cube plus 2 1.30 square plus 10 into 1.30 minus 20, which gives us so use your calculator and find the value of f of 1.30, which we have here is minus 1.42. Now the value of the function at 1.30, which is c naught, is minus 1.42, which is negative. So on the right hand side on the interval, we will put the sign here less than 0 at c naught. Now again look at this interval. Here we have the main interval a naught b naught, which is 1 2, and in between 1 2 or in between a naught b naught we have somewhere here c naught. Again c naught is not in the middle, it's somewhere in between a naught b naught. So we have to find the next interval. The next interval, either this is going to be a naught c naught or it is going to be c naught b naught. Remember that the appropriate interval is the one on both ends the values of the functions are of opposite signs. Now please see this. A naught, C naught have the same signs, less than 0, less than 0. But C naught, B naught have the opposite signs in this interval. So we will copy the second part of the interval, which is this one. Here on the right hand side, we are copying C naught, B naught, but we will not copy the notation C naught, B naught. We'll copy 1.30 on one end, on another end, because this part of the interval is the right one. 1.30 on one end, and on another end we have 2. And f of 2 was positive, so I'm putting the sign. F of 1.30, which was minus 1.42, it was negative, so we are putting this sign. And now we will rename this 1.30 and 2 as a1 b1, because this is our next interval. And somewhere in between a1 b1 we will find the next false point and we will denote it by c1. Now we have to find c1. So to find c1, we will put n equal to 1 in equation 1. When we put n equal to 1, we have a1 f of b1 minus b1 f of a1 over f of b1 minus f of a1. So this gives us c1 as a1 f of b1 minus b1 f of a1 whole divided by f of b1 minus f of a1. At this point, to find c1, we have all the values to plug on the right hand side of c1. That is, a1 is 1.30, that you will pick from here. b1 is 2, that you will pick from here. b1 is 2, a1 is 1.30 whole divided by f of 2 minus f of 1.30. Let's plug in the values. 1.30, f of 2, you will see in the beginning you have the value of f of 2, which is 16, minus 2, f of 1.30. See here we have found this value f of 1.30, which is minus 1.42 whole divided by f of 2 is 16, f of 1.30 is minus 1.42. Use your calculator to find this value c1, which is 1.36. On the right hand side in this interval, we will write c1 as 1.36. So somewhere in between a1 b1 interval we have found c1, which is 1.36. Now we are going to find f of c1. Every time you find a false point, here c1 is a false point, we are going to plug this in the function. So we plug C1 in the function, we get f of 1.36 is equal to, we plug this in the function, 1.36 cube plus 2 1.36 square plus 10 into 1.36 minus 20, and we have f of c1 or f of 1.36 as minus 0.19. Now let's look at this interval C1 on the right hand side. So C1 is 1.36 and f of C1 we got as minus 0.19, so it's a negative number, so we will put here the sign less than 0. Please know that C1 equal to 1.36 is not less than 0. The value of the function at 1.36 is less than 0. So now, first of all, shall we stop at f of 1.36 as minus 0.19? No, we will not stop. Remember, our goal is to find some number c such that it gives us some 0.0 some digit, or it could be minus 0 is same as 0, so even if we have minus 0.0 and some digit, that is where we will stop. Since we don't get 0 after the decimal here, so we will continue. Now look at this interval. We have to now pick the next half interval, which is the appropriate one. So the next interval is a1c1 or c1b1. So the appropriate function is the one where on both ends we have the opposite signs of the functional values. We can see that the signs on a1 and c1 are same, but the signs on c1 b1 are opposite. So this is our the appropriate interval. We are going to copy this interval on the right hand side. So C1 is 1.36, we will write 1.36, and B1 is 2, so we will write 2, and we will copy the signs. F of 2 was positive, F of 1.36 was negative, so we have done that. And this time we are going to name it as A2, B2. And now we are going to find somewhere in between A2, B2 as C2 as our next false point. So to find C2, we will put n equal to 2 in our equation 1. So this is our equation 1. Here we put n equal to 2. So we get C2 as A2 f of B2 minus B2 f of A2 whole divided by f of B2 minus f of A2. Let's plug in the values. A2 we have 1.36, it is from here. B2 is 2, it is from here. B2 is 2, A2 is 1.36 whole divided by f of 2 minus f of 1.36. Let's plug in the values. 1.36, f of 2 is 16 minus 2, f of 1.36 we have calculated it, it is minus 0.19, see from here, whole divided by 16 minus 0.19. Now when we use calculator and do the computations, we have C2 as 1.37. On the right hand side, we will write C2 as 1.37. Every time we find a false point, like here C2 equal to 1.37, we are going to find the value of the function at that point. So we will compute f of C2, which is f of 1.37. We have the function. We will plug in the function 1.37 in the places of x. And this gives us f of C2, f of 1.37, 0.03. So our goal was to find a number such that when we plug it in the function, we have on the right of decimal 1 0 and some digit. And now that we have that situation, so this is where we will stop and we will say 1.37 is the root of the equation, the given equation f of x equal to 0, correct to 1 decimal place. We can say that here this number, we can round it up and can say that 1.4 is the root of the equation x cube plus 2x square plus 10x minus 20 equal to 0, correct to 1 decimal place. So this is how we find the root of an equation by using false position method or Regula-Falsi method. So to find the false points, we have this formula Cn equal to An f of Bn minus Bn f of An over f of Bn minus f of An. So we keep on choosing appropriate intervals and we find the false points in between those intervals, and one of those false points is going to be the root of the equation that we are looking for. So this is where we shall stop, and in the next video we'll talk about how to find the root of an equation by using Newton-Raphson method.